Good day. This is a typical function question where a straight line and parabola is combined, and typical questions that you can run into. Here we have a parabola that is called f, and they gave us the full equation of that. Here is a straight line they call g, and they gave a piece of the formula to us. They said D is the turning point of the parabola, and C is the y-intercept of the straight line and the parabola. And they also said that DE is parallel to the y-axis. Then they gave us A and B, the x-intercepts, with the coordinates -3 and 0 and 5 and 0. Firstly, they asked us to determine the value of k. That is the k we have in the part of the formula of the straight line. There's two ways to do it. One way is you have a coordinate on this line. So the straight line goes through the coordinate 5 and 0. You take the 5 and 0 and you plug it into this equation. You substitute the naught in the place of the y and put the 5 in the place of the x. Then -3 times 5 is -15, and then k equals to 15. If you take the -15, you plus 15 on both sides, k is equal to 15. This answer is worth 1 mark, and the final equation of g of x is then g of x is equal to -3x plus 15. You could also have seen that there on the parabola, the y-intercept was 15. That means you know that C is 15 and that the straight line can also use the same 15. Next, for 3 marks, they ask us to work out the coordinates of D. But in the beginning of the video, I told you that D is the turning point. So we're working out the coordinates of D, the turning point of f of x. To find the x of the turning point, we use the formula x equals to minus b over 2a. From the equation we know that a is -1, b is +2, and c is the +15. We substitute that into the formula in brackets and we get the answer of 1. Then you take your equation again, you replace the x value with 1, simplify it and you get the y value is 16. So the coordinate of D will be 1 and 16. That is the coordinate over there. Next they ask, for which x values is the f graph increasing? And the answer is, x is an element of from -infinity up to 1 at the turning point. If you put your finger on any graph on the left hand side and you move along the graph and your finger goes up, it's ascending. At the turning point it doesn't ascend or descend. And then it descends if your finger goes down. This function is going down all the time. Next they ask, calculate the average gradient between A and D, between that point and that point. Use the normal gradient formula, m equals to y2 minus y1 over x2 minus x1. In this case, in other words, the gradient of AD is the y at A minus the y at D over the x at A minus the x at D. Substitute in the coordinates. At the top it will be 0, -16 over -3 minus 1. We simplify it and the average gradient between A and D will be +4. Next they ask, work out the length of DE, that red piece between D and E. It was given in the beginning that the line DE is parallel to the y-axis. The coordinate of D is 1 and 16. The coordinate at E will be 1 and we don't know what the y value is. E lies on the graph of G. So we take this coordinate of 1 and y and substitute it into the equation of g of x. So we get y equals to -3 in a bracket 1 plus 15. -3 plus 15 is 12. The coordinate of E is then 1 and 12. D is 1 and 16. So the length of ED or DE is 16 minus 12, which is 4 units. The difference in y from there to 12. And you just write DE equals 4 units. Next they say h of x, a new function, is a transformation of f of x. So something happened to the parabola to give us h of x. And they ask, write this h of x in this form. What this transformation means is that we'll take the f graph, that means this parabola, move it 1 unit to the right and 2 units down. But to find the equation, we'll replace all the x values with x minus 1 and then minus 2 from everything. One way to do it is take the original equation of f of x, substitute x minus 1 everywhere in the place of x, and minus 2 from everything. Now you can just do some algebra, square out this bracket, get the answer, times the 2 into this bracket, and simplify. Then you simplify further, and you get h of x equals to minus x squared plus 4x plus 10. But now it's not written in this form. Now we do completion of the square on this. Please look at the video on this channel that says completing the square. So we take this new equation, do completion of the square. First we take out a minus from the first two terms. Then we add in the quotient of x divided by 2, all in a bracket square. And then we minus that out again, close the bracket and keep the plus 10. Then we finish completing the square in the square brackets, times the minus back into the square bracket, add the 4 and the 10, and then we have h of x written in this form. There is a second method. You can take f of x and do completion of the square on it first. Like I said, we take f of x, the original parabola's equation, complete the square on it, and get f of x now to look like this. So this and this is the same thing. Now we substitute the x with x minus 1 and minus 2 from everything. So we take this x and replace it with x minus 1 and minus 2 at the back. So then look like this. Just simplify it to get the final answer, which is the same as the previous one. Please stop the video and get your brain around this. The next question is a level 4 question. It says here, determine the maximum value of p of x, a new graph. And now they put a 3 here as a base. There's a little piece of f of x that we have over here, minus 12. The maximum value of f of x is 16. That y of that turning point, it doesn't go any higher. So the maximum of f of x minus 12, I take that 16 minus 12 is 4. So the biggest number I can now get is 4 so far. So 3 to the power of 4 is the biggest answer I can get. So the maximum value of p of x is 81. So p of x equals to 3 to the power of 4. So the biggest number I can get in the area with this 3 would be a 4. It was a 16 minus the 12. So any base, to get the biggest number you can get, you must get the biggest number in the air. Get your head around that. So the maximum value of p of x is 81. The next question asks, determine the value or values of k for which f of x plus k is equal to 0 will have two distinct real roots. So we can write it down like that. Rewrite the formula of f of x and then plus k equals to 0. In this equation now, a is minus 1 in front there, b is plus 2 there in front of the x, and 15 plus k is my c. From the nature of the roots we know, our discriminant must be bigger than 0 to have two distinct roots. So the discriminant is b squared minus 4ac. We substitute these numbers into the formula and we get this. Simplify and simplify further. So my discriminant is now 64 plus 4k. But to get two distinct roots, this must be bigger than 0. And then we just solve for k. So 4k is equal to minus 64. Divide by 4 on both sides. K is bigger than minus 16. That will give us two distinct real roots. There's also a graphical way you could have done it. You can say f of x plus k equals to 0. Take the k to the other side. So f of x equals to minus k. And draw a line right here at D, which is y equals to something. And then you know that the y value here is 16. So y equals to 16 will touch this graph. But if it comes down, it will have more than one place where we will have answers. So this line, y equals to minus k, must be smaller than 16. So minus k is smaller than 16. Divide by a minus on both sides. So k is bigger than minus 16. The same answer we got here. If you don't understand this, stick to this. The last two questions of this video says determine the values of x for which f of x is bigger than g of x. They're asking where is f of x above g of x. There is no equal there, so we exclude the crossing where the two lines intersect, and everything in between there is where the f graph is bigger than the g graph. And write your answer in interval notation, x is an element of excluding 0 all the way up to 5 excluding 5. Or you can write it in set builder notation, x is bigger than 0 and x is smaller than 5, x element of real numbers. Stop the video and get your brain around this, please. The last question of this video is asking, where is x times g of x smaller than or equal to 0? There's three things you must look out for. Where is the x positive and at the same time the g graph is negative? And also look where they are equal to 0 each. The x is 0 over there and the g graph is 0 over there. We color it in and use it. So x is positive on this side of the y-axis and the g graph is negative under the x-axis. So we want the x values on this side. So a piece of my answer is x is bigger and equal to 5, x element of real numbers. You want the x values on this side of 5 and including the 5. But we also have to look where x is negative while at the same time the g graph is positive. So we're looking where x is negative and the g graph is above the x-axis at the same time. All x's are negative on the left-hand side of the y-axis and the g graph is positive everywhere from the x-axis up. Now we need to find out what x values satisfy both of them. If you go up here, you'll see from 0 towards the left, the x's are negative while the g graph is positive. So my final answer is x is smaller than or equal to 0 or x is bigger than or equal to 5, x element of real numbers. You can also write it in interval notation like this, one of the two methods, the one that suits you. Please indicate whether you liked or disliked the video and subscribe to the channel.